So in this video, we're going to look at solving for x in the exponent. I've got two examples. Should be a fairly quick lesson. So let's look at the first one. We've got 5 to the x equals 40. So whenever we're solving for a variable in the exponent, typically when we first start doing this, we look at, well, let's make a table. It'd be 5 to the first is 5. 5 squared is 25. 5 to the third is 125. So I know the answer is 2 point something because 5 to the 2 is 25 and 5 to the 3 is 125 and 40 is in between those two. Typically, most students will say, well, divide by 5 and you'll get 8, but that's not true. 5 to the 8th is much, much bigger than 40. So what we have to do instead is we're going to take the logarithm of both sides. And when we do that, we get log of 5 to the x, and it's always base 10 when you take log. You could do any base, but base 10 is what our calculator uses, equals log of 40. Excuse me. So then what we've learned is that on a logarithm, if the exponent on the number, we can pull that out in front. And so we have x times log of 5 equals log of 40. And then we just divide both sides by log of 5. And so then we get x equals whatever that is. Now, it's tempting to want to cancel out the logs, but you cannot do that. Log is an operator. It's like saying canceling out multiplying on top and bottom. You don't do that. So log is just a button on your calculator. Let's go do that. So log of 40 divided by log of 5. Log 40, close parentheses, divided by log of 5, close parentheses, and we get 2.292. So the answer is x is approximately 2.292. And that's what we guessed was somewhere between 2 and 3, and that's what we got. All right, so there's our first example. So basically the moral of the story is if you want to solve for x, you got to do the log of both sides and then do your algebra and plug it in your calculator. So let's look at example 2. We have 7 to the 2m minus 1 equals 0.007. So we are going to take the log of both sides. We get log of 7 to the 2m minus 1 equals log of 0.007. Now, the title of this was solving for x in the exponent. It doesn't have to be x. It can be any letter you want. I purposely chose m here so you knew it didn't have to just be x. But when we're solving for an unknown in the exponent is really what we're doing. So, just like before, we're going to take this exponent and pull it out in front. You can do that with logarithms, only with logarithms. 2m minus 1 in parentheses times log of 7 equals log of 0.007. So then since this is multiplied, I'm going to divide by log of 7. We get 2m minus 1 equals log of 0.007 over log of 7. And then if I want to solve for m, I'm just going to add 1 to both sides. I've got 2m equals log of 0.007 over log of 7 plus 1. And then to solve for m, we're going to divide both sides by 2. So m is going to equal all of this stuff. That would be technically our exact answer. If we wanted to get a rounded answer, we would just type that into our calculator. So let's do that. Log of 0.007, close that, divided by log of 7, close that, and then add 1. And we get negative 1.54988. And then we're going to divide it by 2, like we have in our equation, and we get 0.775 approximately. So m is about 0.775. And there we have it. Just, oh, I'm sorry, it's negative 0.775. I was double checking. I thought I maybe missed that. So negative 0.775. So once again, moral of the story, if you have an unknown in the exponent, you're going to take the log of both sides and then do your algebra and you'll get your answers. So that's for solving for x in the exponent or whatever letter you choose in the exponent.